Hello everyone, welcome you all to the series of MATLAB tutorial. In the last session, we have covered MATLAB Transpose. Now we will learn about MATLAB Matrix. We will begin by theory of what is matrix in the MATLAB, then referencing elements in matrix, how to delete either row or column in a matrix, different matrix operations, applications of matrix, and at the end, as usual, for your better understanding, I'm gonna keep this session mixed with the theory part along with the live demonstration of the MATLAB scripting examples. So let's start. What is MATLAB matrix? In MATLAB, a matrix is a two-dimensional rectangular array of numbers and is the fundamental data type for calculations. Since MATLAB is a matrix laboratory, it is designed to operate preliminarily on the matrices and arrays, making it ideal for linear algebra and data analysis. A matrix is a two-dimensional array of numbers. In MATLAB, you create a matrix by entering elements in each row as comma or space delimited numbers and using semicolons to mark the end of each row. In MATLAB, even a single number is stored as one by one matrix. Now let's see what is referencing elements in the matrix. Referencing elements in a MATLAB matrix is a fundamental concept for accessing, modifying, and manipulating data. Let's look a basic syntax and then see how referencing works in the MATLAB matrix. So here I wrote a very simple statement that is A is equal to 1 space 2 and then I use the semicolon, then 3 space 4 and then I close the square bracket and again the semicolon. Very simple syntax I'm gonna explain you here. So how it looks actually. So it looks like this. So it starts with, here are the two columns created because the dimension of this matrix which I have created here is 1 and 2 are basically, if you see here, it's A is equal to 1, 2, then semicolon 3, 4 is basically the matrix created and the size of the matrix is 2 by 2. Now this is how it looks. So you're gonna get two rows and the two column. In the first row, we are getting the value 1, 2, and in the second row, we are getting the value 3, 4. And this is how the very simple example how you can represent the matrix in a MATLAB. Now, here we have created the matrix that is A, which is shown on the right side. And now let's see how we can referencing the elements either by entering row or column. So let's see one by one. So starting with referencing a single element. Okay, so here either you can use the number of the row and the column with the braces and directly you can get the result. So here what I have done here as a simple example, A with a value of passing 1 comma 1, that means here we want to refer the value with the first row and the first column. And here is our matrix. So first row is this and first column is this. So I'm gonna get the 1 as a result. So as a result, it returns the value of a 1. Now looking for the second example. So if I wrote here like 1 comma 2, that means the first row, and always remember in matrix, the first element passed is always the number of the rows presenting, and the second always is the number of the columns. So here, what I want to return the value of the first row and the second column. So here is my first row and the second column. That means that this. So ideally, we should get the value 2. So let's see. And here we gonna get the return value from the MATLAB is 2. Third is a 2 comma 1, that means the second row and the first column. Then we get the return as a 3. And the last element which we want to access with the help of the number of rows and the column is 2, 2 means the second row and the second column, and it returns the value 4. Second is the referencing entire row or column. So in the entire row and column, let's see how whole row works. So to access the entire row or the whole row, it's very simple. What you have to do, you just have to use the one. That means I gonna access the first row, and this colon symbol earlier, that is comma put and then use the colon symbol. That means I want all the columns in the row 1. Okay, so here is the row 1. I want all values here, and that is the reason if we write this way the syntax, you will get the result as 1 2. Very simple. Now the whole column. So what will happen in the whole column? Rather to write here the specific number of the row, here the semicolon, the colon symbol is used, and then the comma. Colon means all elements, but of the which unit, that is the second column. So all rows in the column number 2, we want to return the values. So we will get the 2 and 4 here because this is the second column. Okay, and this is the second column, and we want all values. This colon symbol means basically all values, and this is how we're gonna get the all values. Now, referencing multiple elements, you can access multiple elements at a once, and the syntax is very simple. Here what I gonna do is, here let's do the access for the multiple elements at a once. With the help of this syntax, I gonna get all the values. So what is written here, the element in the first row and the second of column number 2. Here column number 2 is referred, but what elements in the first row is first and second of the second column, and that is the reason we got the result 2 4 here, and here we are getting the 2 4. Now the another way I can do, or either to write this element in the row first and the column 1, I gonna get the result like this 1 2. Now let's look for at the summary table how it works, the referencing elements. So here is the summary table. So as I said earlier, to save your time, I already have created the example. And this is a MATLAB script written, and this is a command window. Here, what I'm gonna do, I'm gonna start with creating the matrix, and that is size of a 3 by 3. A is equal to 1, 2, 3. Then I have used the semicolon. That means it refers that we're gonna enter to the new row, that is 4, 5, 6, and then again semicolon, and 7, 8, 9, that is a third row. The first example I'm gonna show you here is the reference single element. And in this, what I have done, I have used a variable called element is equal to, that is a of 2 comma 3, and here this resulting the value stored at the row number 2 and the column number 3. So if we refer the matrix A, 1 2 3, this is a first row, and then 4 5 6 is a second row, that means the second row, and the third column. So 3 6 9 is on the third column. So the second row is 4 5 6, and third column is this, so 6. So ideally this result should show us a 6 value when we referencing the single element with this syntax. We will see the results at the end, but just wanted to show how I have used this MATLAB referencing examples here. Now reference a entire row. So let's refer the second row, and that is why it is started with the 2, that is second row, comma, all elements. When I use the colon operator, that is this double dot, that means the colon operator, MATLAB understand you want the all elements. Means all elements actually, but as it is placed on the column place. So that means all elements of the column. And which row? This is second row. Ideally, it should reflect the 4, 5, 6 because this is second row and the all columns it is wrapping. This 4 will fall into the first row, second row, and third row. If we are, sorry, first column, second column, and third column, if we are wrapping the columns. So ideally, we should get the value 4, 5, 6, and then that we will see at the end and referencing entire column. And here, column number 3, I want to refer here, and that is the reason here this colon operator used. That means all elements of the rows, and the column I'm referring here is a third column, and that is the reason I also refer the column number 3 as an column 3 as a variable here for better understanding. Next, under this element referencing is, so ideally this, what should this return actually? When I say column 3 and use this syntax, that means it should ideally return 3 on the first row, 6 on the second row, and 9 on the third row. So we should get the 3 rows, but how? Column, if you look at the column, then the 3, 6, and 9 ideally we should get. So we will get all rows, but so ideally we will get the 3 rows, and values are like 3, 6, and 9. In the first row we will get only 3, second row we will get only 6, and third row we will get only 9. We will see the result later. And the last example, that is reference a submatrix, means some part of that matrix I want to refer. And here I want to results the rows of 1 to 2 and the columns 2 to 3. And that is the reason this operator is 1 to 2 and 2 to 3. But when I place this at the first place, it means it is referring the row, and when I put this here in the second place after comma, that means it is a column. So row and column. And I have covered this in theory, how the matrix works or how the matrix syntax works. There I have clearly mentioned the first part before the comma is always representing the row, and the second part after the comma always representing the column. So the rows 1 to 2 and the column 2 to the column, yes, column from the 2 to 3, and that I want to store the value as a part of submatrix, that is a sub A, and want to see the results. So let's see, ideally here I should get the value 2, 3, and 5, 6. That is the only thing we should get here. If we 1 to 2 and 2 to 3, that means here if we are referring, then we should get 2, 3, that is this, and we should get the 5, 6 from here, because we are referring only 1 and 2 rows, and we are referring column 2 and 3. So this 2, 5, 8 falling into the second column, 3, 6, 9 is falling into the third column, and that is the reason we will get the value 2, 3, 5, 6. Now if I run this entire script, what I have done here, I wanted to first show you the elements at the place of 2, 3, how it looks, and the result should be 6, as I explained earlier. And if I want to see the row 2, and it will display the entire row, and then the column 3 into the column 3, this will display the column 3, and the submatrix, it will display like 2, 3, and 5, 6. Let's see how it looks. I'm gonna click here and run this entire script, and here are the results. Let me drag this up here, and here are the results. So the first operation we performed, that is referencing a single element, and the element we were referring at a 2, 3. And if we look at the matrix, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. The second row, that is 4, 5, 6. And the third column, that means this 3, 6, and 9. So ideally the 6 should be there, and here we got the result 6. Similarly, for the second referencing the entire row, I want to refer the um, elements into row 2, and in the row 2 it's a 4, 5, 6, and here is the result 4, 5, 6. And in the third was little interesting, there all rows but the third column, and the result should be 3, 6, 9. That means we will get all rows, but only from the third column, that is 3, 6, 9. If you see the all rows, but third column 3, 6, and 9. So it entered into the all rows, but only the third column has been selected. And here we get the size of 3 by 1 ideally here. And the last example I wanted to showcase here was the referencing a submatrix. So if you see here 1 to 2 and 2 to 3, that way if we refer, as I explained earlier, the results row 1 to 2 and the column 2 to 3 is a 2, 3, 5, 6, and here the result is 2, 3, 5, 6. So this is very simple examples how you can use the operations that is called referencing elements in a MATLAB matrix. I have presented here. Now it's up to you how you can use the feature of this MATLAB matrix elements referencing in your programming. Now the interesting topic on this MATLAB matrix is to delete a row or the column from a matrix. Let's look on this. To delete a row or columns from a matrix in MATLAB, you assign an empty array. We just have to use a square braces and just pass nothing over. That means the empty array to the rows or columns you want to remove. You use the standard matrix indexing to specify the elements to be deleted. So very interesting here. Let's create a simple matrix here. So here I'm going to create a simple matrix that is with the value of A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And this is how the matrix is created. In the first row, I'm going to get the value 1, 2, 3, 4. Second row, 5, 6, 7, 8. Third row, 9, 10, 11, 12. And fourth row is a 13, 14, 15, 16. Remember, in MATLAB, number of column and the number of row never start with the zero indexing. It start with the 1. So whenever I say the first row, that means the 1, 2, 3, 4. It is not the zeroth row. When I say fourth row, it's a 13, 14, 15, 16. Here we have created a simple matrix. Now let's work on this, how we can delete the rows and columns and learn about how it works in the matrix. Okay, now we have created the matrix and the values written here that A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Accordingly, the value is written. And now let's see how the delete a single row works. To delete a single row, specify its index and assign an empty array. And so what I'm going to do here is I'm going to select it by using the A and the second row, comma, I used again the colon symbol and close the braces and assign an empty array. So let's do that. So A into braces in the bracket 2, that is the second row, and then comma and the colon symbol, and I close the bracket and assign the empty array over there. Okay, so here you're gonna get the results. So what I have done, I have deleted the second row. If you see at the right side of the image, this is original matrix. After doing the operation on this, deleting the second row, if you see the 5, 6, 7, 8 has been deleted here. And this is how you can delete a single row. Now let's have a look on again the another example. To delete a single column, specify its index and assign an empty array. Select it by using again the syntax that is A, and here I have used the colon and then comma 2 and assign and then empty array over there. So I'm gonna use this syntax and assign the empty array. So what will happen here? The second column will get deleted. Let's see the result after executing in the MATLAB. The second column has been deleted. That is 2, 6, 10, 14 has been deleted, and the size of the resulting matrix is also changed. The size is earlier it was 4 by 4. Now the size is 4 by 3. 4 rows and only 3 columns because second column has been deleted. And this is how you can delete column as well. Now let's look for delete multiple rows or the columns. How you can do delete the multiple rows and the column. So delete specific row. To delete a row 1 and 3, use the index vector that is in the square bracket 1, 2. Select it by using a syntax that is a of 1, 3 and then use a comma and again the colon symbol and assign an empty array. What we are going to do here is we are selecting row number 1 and column number 3. And here is I use this syntax, assign the empty array, and let's look for the result. And here is the result. So you're gonna get only the second row and the fourth row because the first and the third row has been deleted. So first was 1, 2, 3, 4. Third was 9, 10, 11, 12. So that is deleted, and this is how it works to deleting the multiple rows at the same time. Now delete a specific columns. To delete a column 2 and 4, use an index vector that is in the square bracket 2, 4 and use this syntax that is a of colon, then we have specified the number of the columns which we want to delete, and then we're gonna assign the empty array to this, and this is how the syntax will work. And the result you will get here, the second column that is 2, 6, 10, 14, and the fourth column that is 4, 8, 12 and 16 has been deleted. You can even delete based on the conditions, and let's see how it works. You can also use logical indexing to delete a row based on a specific condition. We're gonna take the example here to delete all rows where the value in the first column is less than 5. Very simple logic is written here, and we're gonna check here the value that is 5, and here all rows. That is the reason this is given all rows in the first column of A, and we're gonna check if that is less than 5, and we have assigned here. If you see here is all columns are considered, and we are doing the operations on the row that we want to delete the rows and assign the empty bracket. So let's see how the result looks. So you're gonna get the first, if you see the 5, 6, 7, 8 we got because that is the only row whose value is less than 5 and it has been deleted. So we're gonna get 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That is row second, third and fourth we got, but the first row has been completely deleted because its value is lesser than 5. Now time for the delete a row and the column examples in the MATLAB. As usual, to save your time, I have already created the script and we will go through it, but it is covering all the basic areas of matrix with deleting the rows and columns and so on. So here is the script I created, I opened, and we will see the one by one examples. At the first, I'm going to create the matrix, and this will create the matrix with the size of 3 by 3. If I select this section and use the keyboard that is Control Enter, it will create and you will get the matrix as A in the workspace with the value of 1, 2, 3, 4, 5, 6, 7, 8, 9. That means the 1, 2, 3 is on the first row, 4, 5, 6 on the second row, and the 7, 8, 9 on the third row. That is 3 rows and the 3 columns. First example and the very simple example, that is delete a single row. If I select this section and enter Control Enter, I just want to delete the second row out of this 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I hit the run button, that is the Control Enter, the second row is deleted. The second row was 4, 5, 6. And here is the result, only the first row and the third row. And this is how you can delete a single specific row, but you need to mention the row. This is a row and this is a column. All elements of the column are expected. Only the second row with the empty, that means we are deleting that. The next example is delete a single column. Deliberately, I copied this matrix here and I put here. The reason is by putting that, if I just come here and enter, it will take the A as a value of 1, 2, 3, 7, 8, 9. Rather, to take the original matrix. To get the original matrix in the subsection of this MATLAB script, I copied the matrix A 1, 2, 3, 4, 5, 6, 7, 8, 9, and I want the operation on that in the lateral line, that is deleting a third column. Entire a third column I want to delete. All rows third column with the empty value, and that is assigned. That means the third column will be deleted. I will come here. Before that, let me clear the screen, clear the workspace. Not required to clear the workspace as well, because I'm gonna create this another matrix with the same values, that is 1, 2, 3, 4, 5. So here, if I come and use a control enter button from the keyboard, you will get the result. A was earlier like 1, 2, 3, 4, 5, 6, 7, 8, 9. That was a 3 by 3, 3 columns, 3 rows. But the third column is been deleted. That is the first two. Third here, 3 was here, 4, 5, 6, 6 was here, 7, 8, 9, 9 was here. That the third column itself deleted. And this is how this works. Let's look for the next example, that is deleting multiple rows. I want to delete the multiple rows. Okay. Here I kept the all columns, but rows I want to delete the first and third. If I consider this is a original matrix with the value 1, 2, 3, 4, 5, 6, 7, 8, 9, what I want to delete 2, 1, 2, 3, and 7, 8, 9, because this is a first row and this is a third row. Let's run this section and see the results, and here is the result. So you get the results only the second row, that is a 4, 5, 6, and this is how we are deleting the multiple rows. You can delete the multiple columns as well. The simply, rather to write here, we need to write here, and the column will be on the first place, that is on the row. So all elements of the rows we are keeping, and the second, third column we want to delete. If we want to delete second and third column, that means 1 will be reflected only, 4 will be reflected, and the 7 will be reflected. Let's look how the results comes here. With it should show the 3 by 1 matrix, and here is the result, that is 1, 4, 7, that is 3 by 1 matrix. And the last I want to show, that is I covered in the theory part as well. I want to delete based on the condition, and the condition I put here is delete all the rows where the values in the first column is less than 5. So let's find that first column where the value is less than 5. I want to delete that, and if I come here, again the matrix is created, the syntax is written here. If I use the control and enter, and you will get the result 7, 8, 9, because uh, here in the all elements of the first column, and it checked the value lesser than 5, and it found only the last row. We want to keep the all columns, right? So last row only is passing this criteria, and that's the reason we get this value. Let's change this as a 3 or something, and let's look how the results comes. So here, if you see the 4, 5, 6, 7, 8, 9, that is how I get this also and this also, because this is filling the criteria. Here, 1 and 2 are lesser than 3. So that is the reason it is deleting this. If I write like, let's say, even if I write 6 here, this 4 and 5 is not passing criteria. 6 is passing criteria, but 4 and 5 is not passing criteria. So this will delete and only get the 7, 8, 9. So if I enter, you get the 7, 8, 9. Let's check what happens if I write like 9 here. Ideally, we should get the blank. So let's look, control enter. So it's empty. And that is the reason you get the 0 by 3. It's a blank, that is an empty double matrix. And it has given us that it's empty, because none of the condition is passed. None of the row has the value is completely, elements value is lesser than the 9, because here it is passing. If I go for the 8 also, the same result I will get. Control enter, again the empty, right? Because this up to this element it is passing criteria, but here also passing, but here it is failing. So entire row is failed. We cannot operate on the specific elements in the specific row. That's not possible. So this is also failed. We are getting the empty value. And this is how you can delete specific rows or the columns based on the condition. And that's all that comes under deleting the rows and column. I just started with the creating simple matrix, deleted a row, single column. I also presented the multiple rows and the multiple columns, how we can delete. And the last condition I showed how you can use the specific condition to delete a specific rows or the specific column. And that is how I have covered. Now it's up to you. These are very simple examples, but now over to you how you can use the feature of this deleting rows and column of the MATLAB matrix in your programming. Let's look for the operations in the MATLAB. In MATLAB, a core aspect of the matrix operation is the distinction between the matrix operations, which follows the rule of linear algebra. Always matrix operations works on the linear algebra. On the other hand, array operations which operate element by element. Matrix operations are fundamental to the MATLAB's functionality because they provide an efficient and high-level way to perform complex computations in engineering, science, and finance. Applications are engineering, robotics, computer science, finance, and economics. And following are the key operations are supported by the MATLAB in Matrix. What are those? Multiplication, division, exponentiation, addition, and subtractions. We will start with matrix multiplication. For a matrix multiplication, A and the star symbol that is used as a multiplication B, the number of column in matrix A must be equal to the number of rows in the matrix B. Then only we can perform this operation, otherwise the error will throw by the MATLAB. Let's look a simple example where we will create two matrices. The first is A is equal to 1, 2, 3, 4, and the size is 2 by 2. As mentioned earlier, the second matrix also should be with the same size, that is 2 by 2. So 5, 6, 7, 8 is created. I'm gonna use another statement that is C is equal to A and then multiplied by B, that is a star. And definitely the result would be 2 by 2. And here is the result. Once you enter in the MATLAB, you will get 1920 and 1450. So ideally, this will do the matrix multiplication. But if you go for doing the element-wise multiplication, then this operation multiplies the corresponding elements of the two matrices of the same size. Here, the matrix multiplication will not happen, the element-wise multiplication will happen. And this is very simple. If we are starting with the same example where we are keeping the two matrices of the same size, that is 2 by 2, A is equal to 1, 2, 3, 4, and then the size is 2 by 2, and the B is a 5, 6, 7, 8, the size is 2 by 2. And you just have to use this dot operator. So if we put this dot operator and the star that is for the production, I mean multiplication of these two elements or the two matrices, then A multiplied by with the B, but the element wise multiplication will happen. Definitely the result will be 2 by 2 and the result will be very simple. If I'm storing that result in the C, the MATLAB will show the results like 5, 12 and the 10, 20, 30. This is very simple multiplication, element wise element. One is multiplied by with the 5, then the 2 multiplied with the 6, that is 12, 3 multiplied with 7, that is 21, 4 is multiplied with 8, that is 32. And this is called element wise multiplication. Very simple. Now let's do some flash on the matrix division, how the division works in the MATLAB while using the matrix operations. The backslash operator. So we're gonna do the left division here, and the backslash operator, that is A backslash B, is known as a matrix left division. Left division is not a direct division, but a specialized tool for solving the systems of linear equation that is in the form of AX is equal to B. We need to understand how we can solve the X with the help of with these two vectors, the matrix that is A and B. And this is how the left division is very powerful and useful there. So whenever we are referring the matrix division with a left division with this symbol, and that symbol is called backslash symbol, That means we're gonna perform the specialized operation or the solving actually the linear equations in the form of ax is equal to 2. So if you have any equation, you just have to form the matrix in the form of ax is equal to b, then you're gonna get the values for the x. Let's do that here. So let's solve the equation that is 2x plus 4y is equal to 10 and 5x plus 3y is equal to 8. So we have to solve for x and y, and one first equation is 2x plus 4y is equal to 10 and the another equation is 5x plus 3y is equal to 8. How it will work? It's very simple. So representing above equations as ax plus b, as I earlier said, we need to represent that in the linear equation form, that is ax plus b. And if these equations we want to solve and represent that in the form of the matrices, then how it will go? Here, so very simple. The A is equal to 2, 4. So this 2 and this 4. Okay. And the this element that x and y coefficient, that is 5 and 3, are presented here in the second row. That is called the first matrix. And the second matrix is presented as the values which are given for this equation, that is 10 and 8. Simple, that is 2 by 1. And if we use in a MATLAB a simple, that is a backslash operation, means the left division, A is left division B. That means A is divided by left division by B. And then here we will get the result of 2 by 1. And the result is like 0.14, and that is a 2.43. Means you are getting the value x is equal to 0.14 and the y is equal to 2.43. Very simple. If you put that value, you're going to get the result for the above equations. So this is how the left division. So it is called as, it's not a direct division, but a specialized tool for solving the systems of linear equations of the form of ax is equal to b. And you have used, and I have given the best example to understand how the left division works in the MATLAB. Now the single quote operator, that is this symbol is called as apostrophe symbol. If you use that, it flips the matrix over its main diagonal and turning the rows into column and vice versa. The dot single quote operator present the non-conjugate transpose, and the standard only the quote operator, the single quote operator compute the complex conjugate transpose. Let's take the example here. If I have taken the A is equal to, or created a matrix of 2 by 2 with the value of 1, 2, 3, 4, size is 2 by 2. I used one variable A transpose and assign that value with the taking the transpose of the matrix A with the help of apostrophe symbol. What we're gonna get here, a transpose will be stored in the A underscore trans value. And here, if I enter this into the MATLAB, you're gonna get the result is 1, 3, and 2, 4. So earlier the value was 1, 2, 3, 4. If you see the A is original matrix, that is 1, 2, 3, 4. But if I do the transpose for this, then we're gonna get the flipped operation on that. That is 1, 3, and 2, 4. So this element is flipped on the rows and the columns. That way it is done. So this is how the transpose operator is being used. Now the power operator. And this power operator calculates the matrix operation, and it requires the base to be the square matrix. Simple example, again the same matrix 1, 2, 3, 4 with the size of A is a 2 by 2. And if I use the power up to, that is I want to calculate the square, then what I'm going to do, actually I'm going to do just multiplication of the matrix, that is A into A. So here the square means square, the same matrix is multiplied with the elements of its own matrices. So multiplication of the matrix happens. It's not element wise multiplication, it's a matrix multiplication. And here we will get the result. So either you can use the square with the power operator, or you can just multiply the two matrices, that is A into A. The result will be the same. Now let's look for the matrix addition. And matrix addition is the fundamental operation that combines the two matrices into a single new matrix. It is an element-wise operation, which means that the element at corresponding position in the original matrices are added together to form the new matrix. Let's take the example again. The A is equal to 1, 2, 3, 4, size of 2 by 2. The B is equal to 5, 6, 7, 8, and the size is 2 by 2. And if I add the matrix A plus B and want to see how the C value get returns with the addition of A and B, here is the result. I'm gonna get the result as 6, 8, and 10, 12. And very simple, that is, if you see here, 1 plus 5 is a 6, 2 plus 6 is 8, 3 plus 7 is 10, and 4 plus 8 is 12. This is how the addition works. Let's look for the matrix subtraction. Again, it is a fundamental operation that combines the two matrices into a single, and that when I say the single, I'm referring the new matrix. And taking the example of the same value with the same matrix, that is A is equal to 1, 2, 3, 4, and the B is equal to 5, 6, 7, 8. And if I use A minus B and want to store the result into the C returns the subtraction of B from the A, and we're gonna get the result is here minus 4, minus 4, minus 4, minus 4. So if you see 1 minus 5 is minus 4, 2 minus 2 minus 6 is a minus 4, 3 minus 7 is a minus 4, and 4 minus 8 is again a minus 4, and that is the reason we get this subtraction this way here. Now time to summarize all the matrix key operations. So let's do the summary here and how it works. So you will get all the operations, how they element wise do the operations, and how it works in the linear algebra in the table form. So here is the table. Now the time for learning the matrix operations in the MATLAB. Here is the MATLAB. And for your better understanding, I already have created the examples and I have captured that into the MATLAB script. The name of the script is matrix operations, and we will open that script and I will show you how I have covered the different. Mostly I have covered the key matrix operations, that is multiplication, then the element-wise multiplication, matrix division, element-wise division, that is another part, that is matrix right division, left division, then matrix transpose, addition, and subtraction. This is how the key operations are covered. And here is the MATLAB script I have wrote, and we will go one by one. Here I'm starting with just defining the two matrices. And the first, my focus is the MATLAB multiplication. So if I select this section here, what I'm going to do, let me enlarge this section. Here, the first focus is for matrix multiplication. Now, let me little bit enlarge this. Yes. Simple example, starting with defining the two matrices, because if we want to multiply, then definitely we need two matrices which we want to multiply. A is equal to 1, 2, 3, 4. The B is equal to 5, 6, 7, 8. Size is 2 by 2 for the both. And I just use the multiplication of two matrices with the star symbol, that is A into B. Here, actual multiplication of the matrix happens. And if I use this dot operator and then the product symbol that is called star, and then it goes for the element wise multiplication. Element wise multiplication is simply multiply element by element, like 1 into 5, 2 into 6, 3 into 7, and 4 into 8. That way the element wise multiplication happens, and the matrix multiplication happens based on the theoretical part, the way the matrix multiplication happens. And so these are the two parts comes under the element wise and the direct matrix multiplication. If I select this section, already selected, you see the blue here. And if I enter Control and enter button from the keyboard, then you're gonna get the result. Let's see the results, how results looks. For the actual matrix multiplication, here is the result, and this is a right, that is 19, 22, 43, 50. You can use the pen and pencil and solve this equation. You will get 19, 20, 43, 50 as an product of the two matrices. But if you go for the element wise, here the element wise multiplication is 5 into 1 is 5, 6 into 2 is 12, 7 into 3 is 21, and 8 fours are 32. And here is the result, that is 5, 12, 21, 32. Simple example, but it gives the idea how you're gonna define the matrix and use the multiplication operations using the MATLAB matrix feature. The next example I'm gonna show you is a matrix division. Before that, let me clear the workspace and clear all, and then clear the screen. And here we are. Now I have created the two matrices. The size of the A is 2 by 2, but the size of the B is, yes, again it's 2 by 2, but the values are 10, 20, 30, 40, and here the 2, 4, 5, 8. So size is 2 by 2, 2 by 2. We are doing the element wise division. And for doing the element wise division, the forward slash is used here, and this is important, dot operator is important. We have seen in the multiplication also, if you use the dot operator, then the element wise operation happens over there. So dot operator and the forward slash, we call it slash or forward slash. A is 10, 20, 30, 40, and we want to do the element wise division with the values stored in the matrix B, and want to store the result in the C and want to display that result. And we will see that result at the end, how this division works there. Each element of the A is divided by the corresponding element of the B. This is what it is done in this line actually. But I want to display this result at the end. So let me go to the another example of the matrix division, that is the right division. And again, for the right division, we use this slash symbol, that is forward slash, but the dot operator is not used. That means we are not doing the element wise operation here. And this performs actually the matrix division equivalent to A and do the multiplication of the inverted B. So if we just B is invertible, then you can just multiply it by A and B. And this is the right division operation works. So B is inverted form multiplied with the A is actually the A, right division B. We will see the result. And the next, which is very interesting, that is the left division. Because this left division is not the way it looks like, just dividing the A by B. So it is used to solve the systems of linear equations of the form of Ax is equal to B, and I have explained this in the theory as well. We can solve the equation, and I have created the equation, the same equation which I explained the theory I have taken here. So this equation we have to solve, and we have to write that equation in the form of Ax plus B. 2x plus 4y is equal to 10, and the 5x plus 3y is equal to 8. So we want to find the value of x and y here, and then we see how the equation, this linear equation, has been solved. Here you can write, this is how it is written. The coefficient of the x is 2, coefficient of y is 4, that is 2, 4, and the coefficient of the x is 5, and the coefficient of y is 3 in the second equation that is written. So this one side is completely written in the one matrix, that is A, and the results of this linear equation, that is 10 and 8, are stored in the another matrix, that is 10. But if you see here, it is not used as a comma, it is used as a, this symbol called a semicolon is used here. That means we are using here 2 by 1 matrix. That is a 2 by 1 size. B is the 2 by 1 and the A is 2 by 2. And just have to use this backslash symbol, and it performs the left division, and then we will get the result actually to getting the solve this 2x plus 4y for the x and y. So everything is done. Now I gonna just to stretch this part to show you. Let me run first this section. So I selected this section. As you see, the blue color is highlighted here. And anywhere if I click and use the control enter from the keyboard, you will get the result. And here is the result. So let me just do this way. So element wise, you're gonna get the result like 5. You see here. Here 2 is 2 divided by 10. I mean the 2 is dividing to the 10. That is 10 by 2. 10 divided by 2 is a 5. Again 20 divided by 4 is a 5. 30 divided by 5 is a 6. And 40 divided by 8 is again 5. This is how the element wise division is done. And the right division here, we used this forward slash, that is a slash of symbol. And here we get the right division, that is 5, 0, 10, minus 10, and the 10. And the last was very interesting, and it's been used for solving the linear equations. That is, the equation is 2x plus 4y. Here the x is presented by 0.1429 and the y is presented by 2.4286. And this is how this is used to solve the equation 2x plus 4y is equal to 10 and 5x plus 3y is equal to 8. Now to prove this, let's do one thing. 2 into what is the value I told you, that is 0.1429 as an x, and plus, or we can do like this, put the bracket here and then plus, and again you use the bracket. uh, what is the equation? 4 into y, that means 4, let's say 4 into what is the y is 2.4286, that is 2.4286. And let's cover this and let's see what's the value we get, and that is a 10. And this is how here it is 10. And simply if you want to prove for the 5x, uh, for this, let's do like this, paste here, cover here, and let's put the value here into the x is basically this value is x. Okay, I'm copying this value, putting here, and for the y also I'm copying this value and putting here. Let's do like this, control V, and we should get it is 8. So this is how we get the 8. So it is proven that the linear equation has been solved, and the first value here is representing the result of the left division is representing x value, and the second value representing the y value. Very interesting. Now it's up to you how you can use the beauty of this left division in your programming and solve the equations. The next matrix operation I wanted to cover here is the matrix transpose. I have created a simple matrix 1, 2, 3, 4, size of 2 by 2, and I use this apostrophe symbol here, which works as the transpose of the matrix A and store the result into the variable called A underscore trans, that is a transpose A. And if we run this, you're gonna get the transpose of the matrix. That's very simple. Before that, I'm gonna clear this section and clear the memory as well. So let me clear everything. Workspace is cleared. This section is selected, and I'm gonna use the control and hit the enter. And here you will get the result. Earlier A was 1, 2, 3, 4, but now it is transpose. That is 1, 3 column is transposed into the rows and rows into the column. So we're gonna get the 1, 3, 2, 4. Very simple example. The next is a matrix addition. And to go for the matrix addition, let me clear the workspace and screen as well. A is equal to 1, 2, 3, 4, and the B is equal to 5, 6, 7, 8. A is a 2 by 2, b is a 2 by 2, and we are just adding a plus b, which returns basically, let me do like this. So comment will go in the next tab. So is a plus b is stored into the C, and we are creating the another matrix that is a C, and the matrix addition is stored into C, and I want to display that. So let's run this section and see how it works. So if I enter, control enter, you're gonna get the result like 1 plus 5 is 6, 2 plus 6 is 8, 3 plus 7 is 10, and 4 plus 8 is 12. Very simple. And the last part is a matrix subtraction. Again, this is also very simple. Same matrix I have used. A is equal to 1, 2, 3, 4. B is equal to 5, 6, 7, 8. And subtraction symbol is used. A minus B and storing the result into C. And this is how I have done the mistake here. Let's correct that. Subtraction. Okay. So here you will get the result stored into C and displayed with the function of disp with the C, that is what the store the result. And let's run this section and see the result. I'm gonna clear the screen and workspace as well. Let's see what happens here, and you're gonna get the result of like 1 minus 5 is minus 4, 2 minus 6 is minus 4, again 3 minus 7 is minus 4, and 4 minus 8 is again minus 4. These are the very simple examples under the matrix operation. I started with the matrix multiplication. There we have covered the multiplication of two matrices, element-wise multiplication. Under the matrix division, we covered the element-wise division, right division, and interesting part of the left division been used to solve the system's linear equation, and matrix transpose, and lastly the matrix addition and subtraction. I think this is good enough for you to understand and start your programming. Now let's look for the MATLAB matrix application. The MATLAB matrix has a wide range of applications across different fields of science and engineering. Here are some common and practical use cases. Starting with the scientific and engineering, it can be used in the signal and image processing, control systems and robotics, structural analysis in civil and mechanical engineering, finite element analysis, that is FEA, uses a matrices to model how forces and stresses are distributed in the structures, and there MATLAB matrix been used widely. Second biggest area is the mathematical and statistical operations, where solving the linear systems, linear regression, and the data analysis and statistics, where the matrices are used to represent the data sets with the row for the observations and columns for the variables. And the last area, that is computer and science and the finance. So it starts with the computer graphics, simulation and modeling, and in the finance, matrices are used to model portfolio risk, calculate asset calculations, and perform other complex financial calculations. After watching this video, I'm sure that you understood what is MATLAB Matrix, matrix operators, and how it works. If you really like this session, then please give the video a thumbs up. To watch more videos like this one, please consider subscribing. Once you hit subscribe button, you're gonna get the notification anytime new contents like that comes out. And lastly, if you have any queries on these topics, you wanna answer me, leave me a comments below. I read them all. That's all I have for you today. Hope you enjoyed and hope to see you next time. Thank you. Bye bye.